Hello, this is Neha. Sorry for the inconvenience. After long days, I am doing this video. This is the further part of the chapter Work and Energy from class 9. In the previous video, we discussed about the definition of work done, definition of energy, types of energy, and mathematical formulation of the kinetic energy. Today we move towards kinetic energy. Kinetic energy is the type of energy. The energy possessed by object due to its motion is called kinetic energy. Means the object gets the energy because of its motion, because of its movement. That is called as the kinetic energy. Formula Ek is equal to 1 by 2 mv square. Ek means kinetic energy of mv square. M is mass of the object, v is velocity of the object. Why we are taking here velocity means the object gets the energy because of its motion. Means the object is in motion means the object gets the velocity. Because of that, we are taking the kinetic energy equal to 1 by 2 mv square. Examples for kinetic energy. Moving car means the car is moving. When the car starts to move, because of that motion, because of that movement, the car gets the energy. That is known as the kinetic energy. Second one, bullet from a gun. When the bullet is fired from a gun, because of that motion, the bullet gets the energy. That is known as the kinetic energy. Third one, flying aeroplane. Fourth one, walking and running. Fifth one, cycling. Because these are all the motion. Because of this motion, the object gets the energy. This is known as the kinetic energy. Next, potential energy. This is the second type of the energy. The energy possessed by the body by virtue of its position is called as the potential energy. Means the body, the object gets the energy because of their position. That is known as the potential energy. Potential energy is nothing but the stored energy of position is referred to as potential energy. Potential energy is the stored energy of position possessed by an object. Means the object gets the potential energy because of their storing, because of their position. When we store the object, when we keep the object at position, because of that position, because of the storage, the object gets the energy. That is known as the potential energy. Mathematical expression for potential energy. Means mathematical formulation for the potential energy. Okay. Potential energy is the work done to take a body to a certain height. Means we know that potential energy means the energy possessed by the object due to its position. When we are keeping the object in that position, that is known as the work done. Means potential energy is the work done to take a body a certain height. When we are placing the object at certain height, reaching the certain height, that is the work done here. For a body with mass m, consider here we are taking one body. Let us consider a body of mass m. H is the distance to which it is raised, and g is the gravitational force acting on the body. Then work done W is given by. Means we have an object, that object of mass m. We are reaching that object at a certain height, that is h, and on that object, the gravitational force from the surface, gravitational force from the earth is acting, that is g. Then we are counting that we are taking the work done. W is the work done. We know the formula. W is equal to force into displacement. Means work done is equal to force into displacement. Force is nothing but the m and g. Means the body of mass m, and it has the force acting on that mass of the object is g, gravitational force. Force is nothing but the gravitational force is acting on that object. The object has a mass m. Because of that one, instead of force, we are mentioning the mg. And displacement means the object is keeping at a certain height from the surface, that is h. W is equal to mg into h. That is equal to W is equal to mgh. M is mass of the object, g is gravitational force, and h is height of the object. As the work done is equal to mgh, which is gained by the object potential energy. EP is given by EP is equal to mgh. Means work done is nothing but the energy. Work done, there is a work is done means that gets the energy. Work done is nothing but the energy. That's why potential energy EP is equal to mgh. M is mass of the object, G is gravitational force, and h is height. When we take the multiplication of mgh, then the product will give the potential energy. This is the mathematical formulation for the potential energy. Examples for potential energy. Water that is behind a dam. We store the water in the dam. That stored water has the energy. That energy is called as the potential energy. Second one, a car that is parked at the top of a hill. We took the vehicle and we parked at the top of the hill. When we store that object, when we kept that object in the height, because of that position, because of that height, the object gets the energy. That energy is called as the potential energy. A yo-yo before it is released. River water at the top of the waterfall. A raised weight. These are all the examples for the potential energy. Then total energy. We know the potential energy as well as kinetic energy. Then total energy means the sum of kinetic energy and potential energy is called as the total energy or mechanical energy. When we are taking the sum of the kinetic energy and potential energy, that will use the total energy. The total energy is also mentioned as the mechanical energy. Equation ET is equal to EK plus EP means total energy is equal to potential energy plus kinetic energy. Then we move towards the another concept, that is power. Power is denoted by P. Definition. The rate of doing work by electric energy is called power. Means the electric energy is a form of energy. That electric energy also do the work. Because of that electric energy, work is also done. The rate of doing work by electric energy means the electric energy is doing the work. When we are taking the rate of doing work, means in the particular interval of time, when we are taking the electric energy in the particular interval of time, that is known as the power. The rate of doing work by electric energy is called as the power. Equation P is equal to W by T. P means power, W means work done, T means time taken. Electric energy is doing the work here. Power means nothing but the work done by the electric energy. That's why we are taking work done. Power is equal to work done divided by time taken. The SI unit of power is watt. Watt is denoted by capital letter W. Then what is 1 watt means? Definition of 1 watt. 1 joule of work done in 1 second is called as the 1 watt. Means the electric energy is doing the work, 1 joule of work done in a 1 second of time. That is known as the 1 watt. Then power is also defined as energy consumed per unit time. Work done is nothing but the electric energy here. That's why energy consumed per unit time. In a given unit time, how much energy is consumed? That is known as the power. Also, under one equation, power is equal to energy consumed by time taken, E by T. Commercial unit of power. The commercial unit of power is kilowatt hour. In our houses, in our buildings, day-to-day lives, we are using that the kilowatt hour. This is the commercial unit for the power. The SI unit of power is watt, but commercially we are using the kilowatt hour. Then what is the kilowatt hour means? We know that 1 kilowatt means 1000 watt. That is nothing but the 10 raised to 3 watt. 1 hour means 3600 seconds. Now we are combining 1 kilowatt hour. 1 kilowatt hour is nothing but 1 into 1000 because 1 kilowatt means 1000. 1 into 1000 into hour means 3600 seconds. When we multiply 1000 into 3600, then we get 3.6 into 10 raised to 6 joule. Means 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. Why we are using the 1 kilowatt hour? The unit of joule is too small and hence it is inconvenient to express for large quantities. Therefore, kilowatt hour is used to measure large quantity of energy. Means joule is too small to measure every time. That is, when we are when we are counting the large quantity of the energy, that time the joule will become very small to express. That's why we are using kilowatt hour. I think this is understood. If you have any doubt, please ask in the comment section. Thank you. Hello, this is Neha. This is the further part of work and energy chapter from the class 9. Law of conservation of energy. Statement. The energy can neither be created nor be destroyed, but it can be transferred from one form to another form. Means a new energy can neither be created and the present energy, the already present energy, cannot be completely destroyed. But the energy is transferred from one form to another form only. Okay, that is, the total energy is said to be conserved. Potential energy plus kinetic energy, that equal to constant. Means when we are adapting the energies, when we are adapting the form of energies, then that will become the constant. That will give the total energy which is conserved in that process. For example, the solar energy. The solar energy is already present in the nature. That solar energy is converted into heat energy, and again that heat energy is converted into electrical energy. That electrical energy is converted into light energy. Here we are converting one form of energy to another form of energy. But we cannot create a new energy and we cannot destroy the complete energy that present in the nature. This is known as the law of conservation of energy. This is the end of the chapter, work done and energy. If you got any doubt in that chapter, please ask the question and in the comment section. Thank you.